Hello, let's place some dominoes. It's time for pips. As is often the case, we've got 1 by Ian and 2 by Rodolfo today. Let's start with the easy. Let's start solving. Okay, so we have 3 zeros all taken here, but we actually have, oh no, yeah, we have 4 in total to use. Okay, the 7 will need the 5 in it for sure. It'll need a 5 and a 2. That's the only way to make that 7. So I think it needs to go down into the equivalence, because otherwise we would need 2 doubles if it didn't go down. It could go either of these ways. No, it couldn't actually go this way. It needs to wait, no, am I wrong? Does it need to go this way? No, sorry, this does work. This does work, actually. I think I was confusing myself there. I was confusing double zeros and double ones for some strange reason. I don't know what I was doing. It doesn't matter. Ignore me. There we go. We finished the easy puzzle. Confused myself more than I needed to. We'll move on to the medium. Okay, so we need 3 of something. We also have a 3 accounted for there. So we need 3 of something, which could be 5s. Maybe only 5s, actually. Yeah, I think it needs to be 5s. Do we have a 5-3? We actually do have a 5-3. So in theory, this could go here in a little corner. It could also go here. Actually, no, it couldn't. Sorry. It couldn't go here, because then we'd need another double 5 if we did that. The only other, and obviously it couldn't go this way. Well, I don't think it could anyway. Well, maybe it could actually. Then we'd need, no, it couldn't. Well, maybe it could actually. Sorry. I just assumed it couldn't, but maybe it can. Because then we'd have a 6-4 here. Oh. No, this does work. Oh, weird. Sorry. Yeah, I'm not... Neurons are not firing with efficiency today, apparently. I don't know why I assumed that wouldn't work, and then I sort of started, as I was saying it, I realized, oh, it would, and then actually it was correct. Okay, fine. Let's try the hard. Hopefully I'm not too out of sorts as we get into this big X-shaped hard. Okay, so 15 could be 3 5s, or it could use a 6, or even 2 6s. The 17, however, needs at least 1 6. So it's either, well, no, sorry, it needs 2 6s. It needs 2 6s and a 5. That's all it can be. It's the only possibility. So 2 6s and a 5. So that this is either double 6 or 5 6. Those are the only possibilities there. So, and how many 6s do we have in total? We have 4. So in theory, we could still, well, I was going to say we could do 2 6s and a 3 in the 15, but that's actually not possible because, is it? Let me think about this. If we had 6 5 here, we could use another 6, which let's just say it's this one, for instance. Yeah, no, we could. We could do 2 6s and then a 3 connecting to a greater than 4. Yeah, actually, that would work with something like this. It might have to be this particular arrangement if it were that. I'm not saying it is, but I just, once again, I didn't want to declare that something couldn't happen and then be wrong like I did just in the previous puzzle, and I almost did it again just now. That's interesting. Let's see if this works. I mean, this 4 region in 3 is fairly constrained, because I've used our only 0 in order to use all of our 6s. So this would have to be, we couldn't make it with 3 1s, so it would have to be something like a 1 and a 2 and another 1. I don't think that works because we don't have a 1 that connects to a greater than 4. Yeah, I don't think that does work, actually. Okay, I think that's the only way that this could have been done. And by this, what I'm saying is the 15 being made out of 2 6s and a 3. I don't think that's possible. I think we need, just because of the dominoes we have access to, I think we need at least 1 5 in the 15. And we need exactly 1 5 in the 17. But we do still have 4 5s in total, so that's not necessarily very difficult. How do we get started on this? I'm not sure. Well, what do we have 4 of? That could go in here. It won't be 6s because we need some of those. And it won't be 5s because we need at least 1 of those. So it could be 4s. We don't have enough 3s. It could be 2s. It could be 4s or 2s. You know, I suspect it's not going to be 2s because I think if we use up all of our 2s, we won't have enough for these small regions. Let's just think about that momentarily. If we used all of our 2s, because we would have to use all of them. Just trying to put them in places where they might theoretically go, not because I'm actually positing these as correct answers. Yeah, this would be really, really hard to fill our other ones without breaking them, but it might be possible. It might be possible. This would have to be 3, 1, and then we'd need a 0 connected to a greater than 4, which would be a 6. This 3 would need 2 more 1s. No, that doesn't work. That doesn't work. Yeah, it's just too. We're using up too many of our small digits. It doesn't work. I don't think. Right. I don't think that can be 2s down there. I think the 4-sized equivalence region needs to be 4s. Yeah, I think it has to be 4s. I think that's all it can be. And how many 4s do we have? We have 5. So we have 1 4 left. I don't know if that necessarily does anything interesting, but not really sure what to make of that, to be honest. What about this 15? So the 17 needs our, well, I was going to say it needs our 6, 5, but it actually doesn't necessarily. We could do double 6 and then put a 5 up there. So we could put the 6, 5 down here and then have a 4. I don't know. I mean, actually we couldn't. We couldn't have a 4 coming off of here because we don't have a 4 connected to something greater than 4. That's interesting. So that can never go there. So if this were here, we'd need a different 5 up here. But again, it's going into a void, so that's not necessarily difficult. And we already determined we couldn't put the 6, 6 there, didn't we? We couldn't have a 3 here. I think I already figured that out. So we can't have, okay, maybe this is interesting. So we can't have the 6, 6 there. We can't have the 6, 5 there. We just figured that out. So what's the next highest thing? Those are equal to 12 and 11. Do we have something that's equal to 10 that could go in there? A double 5. We then need one more 5, which would have to be this 5, 6. We also need a 5 for the 17, which would have to be this one. And the double 6 would, of course, have to be here in that case. I mean, this actually feels like a decent start. Is there anything lower than 10 that we could start that 15 with? Do we have something equal to 9? That would be the lowest total we could put there. But I don't think we do. So actually, I think it has to be this. I think actually that means it has to be this because that would have been the only other possibility. Okay, well, that's a start. So I wonder where our sole remaining 6 goes. I mean, it can't go in there, but it could go in other places. I mean, the inequivalence region, anything could go in there, basically. Okay, and we need to put all of our 4s in the grid. What time is it? Okay, sorry, I need to hurry up slightly here. Yes, we need all of our 4s in the grid. I'm not really sure what I'm looking for here, sorry. I wonder if this greater than 4 is going to be, oh no, it is going to be the 6. Sorry, it's definitely going to be that. That was where I should have looked next, I apologize. So the greater than 4 is definitely 6 because it's the only greater than 4 thing we have left, which means this 4 now needs to be, well, either a 3, 1 or a 2, 2. But it needs to add, it needs to get to 4 in total because we have the 0 there. So that's fine. Okay, should have seen that earlier. Our 3 is getting tricky because now we don't have a 0. So the 3 actually needs to be made up of 3 1s. That's required. And we only have 3 1s. Okay, that is useful. That is useful. One of them is going to point into this inequivalence region. We don't have a double 1, so the others one will point into the greater than 5, and 1 will point down into the 4. So this is the 1, 4 must go here. That is forced. Then the others, this will be either a 1, 3 or a 1, 2. Oops. Or a 1, 2. If it's 1, 2, it's slightly more difficult to make the greater than 5. It would need to be at least a 4. It would have to be exactly 4. So this is the tougher one to do, because the 4 is the highest we have. And the 4 would then have to point down into the 4 region. That's impossible, because then we'd need another double 4 to make that region, which doesn't work. So this is not 1, 2. It's rather the 1, 2 goes here, and the 1, 3 goes here. Now we need the double 4 here no matter what. And this needs to be at least 3 connected to a 4, and that's all we can do. So that goes there. We have our 2, 2 to make our 4, and then we finish our inequivalence region with a 4 rather than 2, and that was the hard puzzle. There we go. That was very good. I was not very speedy, but it was fun once the deductions started coming in. And there we go. That was the hard puzzle, and those were the pips. Back tomorrow. Bye for now.